All right, good morning. We're on that crazy Wednesday that we go to all of our classes. Just a couple of announcements. First of all, be responsible for turning your assignments in on time. I'm not accepting any late work. Keep track of when assignments are due, like either write them in a calendar or keep track of when things are due because I'm not taking any late work. The other thing is I just gave an exam in Algebra 2 and there were two people that wanted to do a retake. I'm not giving retakes for exams. And my opinion about that is if I give one person the opportunity to take a retake, everybody wants to take a retake. So I just feel like it's not fair. You know, if I let one person take a retake, that means I should let everyone take a retake exam. So I'm not doing that. I expect you to be ready for the first exam. Exam on Friday. I've given you a lot of notice about it. It's Friday morning at 8 o'clock, and you're expected to take it Friday morning at 8 o'clock. So what I'm going to honors Algebra 2 students is they're going to get a 0, those that didn't take it. And luckily at the end of the semester, I do throw out the lowest test grade, but if they continue to get zeros, it will destroy their grade. So I'm trying to prepare you for the future. I'm trying to prepare you for college. They don't let you take retakes. You know, you fail a midterm, you just take the class over and pay another $900 or however much it costs to take the class. So I don't want you to ever think that people are going to give you retakes because they're not. So I'm really trying to establish a sense of reality here. So be on time to class so you hear the important announcements. I used to give the announcements in the middle, but now I'm giving you at the beginning because all of you who are late are missing all the important announcements. So make sure you turn your assignments in on time. Make sure that you take exams. I'm not giving retake exams. And make sure you're in class on time so you can hear the important announcements. All right. So the exam is Friday morning at 8 o'clock. It's on 3132. So what I want to do today, I did teach in 3-3. That's not on the exam, but I do want to take questions. Then we're going to spend the rest of the period reviewing for the exam. So anybody want to ask me any questions about lesson 3-3?
Can you do number 13?
Number 13. So it's a natural log of e squared over 5. And we'll read the directions. It says use the properties to expand as much as possible. And where you can get a number, get a number. And it says without using a calculator. Use a calculator because that'll really mess things up and you won't be getting the right answer, getting approximations. All right, so let me pin myself real quick. All right. So to expand means make bigger. So this is going to be the log, natural log of e squared. And this is a quotient, so we're subtracting the natural log of 5. And so there's a couple of ways to do this problem. You could use the power property, but you know that this is log base e, right? So if that's log base e, what's log base e of e squared? So in your mind, you're seeing log base e of e squared. That's what that means. So what happens with log base e of e squared? These are inverses, right? Base of a logarithm, base of an exponent. So what do you get?
2.
So that is expanded. Did you follow that, Mark?
Yeah.
Okay. All right, anybody else want me to work another problem? All right. So today you had extensive practice on 3.1. You a lot of time to study the exam. So personally, I don't believe, because I believe the more time I give you, the more time you have to procrastinate. So I don't believe in giving you more time. But we'll see what happens. Results of the exam. So what I want to do right now is we're going to review 3.2, which are the logarithms. And some of it we're going to be doing because I'm not going to send you to the teams because it's a 10-second problem. So if it's a 10-second problem, we're going to do it in here. If it takes longer, I'll send you to your teams. All right. The other thing is this. Remember what's going on here. Remember how I want you to show your face and I want you to work together. If you do what I want, I'm going to give you some tips for the exam. If you do not do what I want, I'm not going to lift a finger for you. I hope I'm making myself really clear, and I hope you guys get me. So we'll see how it goes when you go into your Math Wizard teams. We'll see if you're showing your face, number one. And number two, we'll see if you're working together. And if you're not, I'm not giving you any hints for the exam. So it's just real simple, black and white. All right, so what we're going to do is we're going to go through each section, and we're going to focus on problems that you need to know for the exam. And so everybody open up your books to page 460. And the first problem you're going to work, so get some paper, get a pencil, get paper. The first problem you're going to work on by yourself is going to be problem number 4. And the directions say, write each equation. It's an equivalent exponential form. So notice all these problems 1 through 8, they're all logarithms. I want you to write it in exponential form, which means you need the definition of a logarithm. And if I were you, I would get in the habit of writing formulas on a sheet of paper. So on your sheet of paper for the exam, you should have the definition of a logarithm for exponential and logarithmic. You should have the properties that I gave you. Log base b of b to the x equals x, log base b of 1 equals 0, right? And b to the log base b of x equals x. You should also have the product property. Well, for the next test on a sheet of paper, you should have the product property, the quotient property, the power property. You should have what the change of base looks like. You should have what expand looks like and condense. So in other words, you should have a cheat sheet, a piece of paper with the formulas on it, so that you're not shuffling, waste time during an exam. All right, so here we go with number 4. And we're not going to have one person answering all the time. I'm either going to call on you or you're going to share. We don't care if you fail, or get something wrong, because we are successful through our failures. So who's going to do number 4? Everybody do it on your paper. 2 equals log base 9 of x. All right, who wants to share? You should be done. Who wants to share how you wrote this logarithm in exponential form? Go ahead, I'm listening.
Will you write down log base 9 first?
You're changing it. Right, so I wrote it down. What's the next step? How do you write it in exponential form?
9 squared equals x.
Thank you. Just say x equals 81, because they didn't simplify. They just have to take the logarithm and write it in exponential form. All right, let's do another one. We'll do number 3, and somebody different will answer. So number 3 is 2 equals log base. How do you write that in exponential form?
3 squared equals x.
3 squared equals x. That is correct. So now you know how to do problems 1 through 8. You want to do another one, or are you guys okay?
I'm okay.
I got it.
All right. So you're going to get that problem right. So now we go to the next section of problems, which is vice versa. So they're going to give you an exponential equation, and they want you to write it in rhythmic form. Everybody write it down. And who wants to share what you got in logarithmic? Write this in logarithmic form now. Well, for sure you have the word log. So go ahead. Who wants to share? Log base what?
Log base 5
Of what?
of 1 over 125
Equals?
-3.
That's correct. So all you're doing is looking at the definition and translating it. That's it. All right, let's do problem number 10. Number 10 is 5 to the 4th equals 625. So I don't want to hear from Jerry or Andres. I want to hear from somebody else. How do you write that?
Log to the 5th.
Log base 5. That's right. Log base 5 of what?
625.
Equals?
4.
That is correct. So that's how we read it. Log base 5 of 624. So say it to yourself. Log base 5 of 625 equals 4. All right, so that's problems 9 through 20. These? Yes, you can. So now you can do 1 through 20. Mark, you okay?
Yeah, I got it.
Okay. All right, so now we go to the properties. And I gave you 3 properties. So you should have those written on a sheet of paper along with the definition of a logarithm. What does evaluate mean? That's what they're asking you to do. What's evaluate mean, class?
Find a number.
Find a number. All right. Who was that answered? Victor, is that you?
Yeah.
Thank you. All right, we're going to do problem number 22. And we're not going to the groups because it should take about all of 10 seconds to do. So first of all, Victor, what did you say evaluate means?
Find a number.
Find a number. So can somebody explain to me, what are we trying to do here? Just, I don't want a problem right now. I just want, let's say that I just walked in and said, you guys, I don't know anything about this. What am I trying to do? What would you tell me? What are we trying to do here?
Simplify the 49.
Exactly, Paige. Exactly. We're trying to make 49 look like a 7, right?
Yeah.
All right, so who wants to tell me? Maybe Paige, you already did it. What's this first step? Paige, you do the first step?
It would be log base 7 to 7 to the power of 2.
Yes. Log base 7 of 7 squared. And so remember what I said about this in that property. I said if you get the base of the logarithm to equal the base of the exponent, they're inverses and they cancel.
So it equals
So what's the answer, Paige?
2.
And Victor, what does evaluate mean?
Find the number.
Found a number, right? All right, let's do another one of these. 23. Log base 2 is 64. I want somebody new to tell me the first step.
Log base 2 of 8 over 2.
8 squared, you mean?
Yeah.
Okay, now listen. That's a good idea. Everybody pay attention. If this was a base 8, that would be an excellent. But since this is a base 2, we want the 64 to be a base 2. You get me?
Yeah, it's 2 to the third power. I put it on my bad.
2 to the third?
Yeah.
Isn't 2 to the third 8? And we want 64.
Oh no, 2 to the 6.
Okay.
Sorry, I'm not focusing.
No problem. And what's evaluate mean, Victor?
Finding the number.
Find the number. Do you guys want to do another one of these or no?
Yeah.
Okay, watch this one. I did not give you one like this, but let's do it anyway. 8 to the base 8 of 19. This is another inverse property like that, because the base of the exponent equals the base of the logarithm. So somebody different, what's the answer?
19.
That's correct. All right, we'll do one more. Number 21. Log base 4 is 6. Now there's different ways you can write 16, right? You can write 16 as 2 to the 4th, 4 squared, but you have to decide which one's going to help us evaluate.
4 squared.
That's correct. So what's your answer?
2.
Good. All right, so now you know how to do problems 1 through 42. Okay, now we're going to be going to our Math Wizard teams because I actually gave you that set of problems that we've already talked about in class. And you're going to have to work these together. I'm going to be checking on you. If you do work them together, I'm going to give you some hints about some heavily weighted problems. If you don't, I'm not going to lift a finger for you. And we're going to be looking at 47, 48, 49, 50, 51, and 52. These are on the exam. And I'll do one for you. F of x. Log base 3 of x. What you want to do is graph this and then pick the graph. If you just look at these, you're going to get them wrong. So you want to know the logarithm goes up along a vertical asymptote. You want to pick 2 points, and you know the asymptote for this is x equals 0. What moves a vertical asymptote, guys? A, B, H, or K? What moves a vertical asymptote?
A.
Yep, H. So if this was log base 3 of x minus 1, the asymptote moves right 1. But it's not. All right. All right, so let's just see if you can do this one. Somebody give me a nice x.
1.
Perfect. What's log base 3 of 1? It's a property, right? And you have it on your sheet of paper, right? What's log base 3 of 1?
0.
Right, good. All right, give me another nice point.
3.
That's perfect. What's log base 3 of 3 to the 1?
1.
So now we look at the graphs. And you're going to tell me which graph goes to which of these numbers. So which one goes, this is f of x. Who does he go with? 47, 48, 49, 50, or 51? or 52. Go ahead, I'm listening.
$52.
52.
That is correct.
To extend your warranty factory
Hold
cutoff.
on.
And this is a courtesy call to renew your warranty before we close the file.
All right. So what you're going to do is you're going to go to your Math Wizard teams. It's 10:40. You're going to be back here at 10:50. And we're going to see if you can get all these right with your team. If you do, you get a point. So you're going to graph them and pick the right one for, which ones are they? Little g of x, little h of x, big f of x, big g of x, and big h of x. You're going to tell me where they go by doing this work. All right, any questions? Okay, make sure you show your face. Make sure you're working together if you want hints about the heavily weighted problems on the exam. All right, I'll see you in your Math Wizard teams. All right, and we're back. All right, so just a reminder, I expect all your devices to be working properly, all right? In my other classes, there's no problems with the video, okay? There's no problems with joining the Math Wizard teams late. It's only with the 12th graders am I having this problem. So we've been doing this since August. If you need a new device, go get one. But I want you to be able to show your face. I want you to get it together. All right? You guys are just about ready. You 12th graders are ready to step out into the real world. Come on now. Got to be responsible. Got to have your devices working. Okay? There's no excuses in my opinion right now. This is crazy. All right? So get it together. All right. Where does F, we know F goes there. Where does G of X go? So which number is G of X?
51.
51, that is correct. All right, where does little h of X go?
49.
49, that is correct. Where does big F of X go?
50.
Yep, good. Where does big X go?
48.
$47. All right, so you will be responsible for working all these problems. Anybody want me to work one? Well, wait, before we do that, team number 1, did you correct?
Yeah.
Okay, team number 2, did you get them all correct?
Yeah.
Yeah? Team number 3, did you get them all correct?
No.
Okay, team number 4, did you get them all correct? No? Okay. Anybody want me to work one of these? Anybody want to see how I would do one?
Oh, can you do the big H?
Yeah. All right, watch this. It's 1 minus log base 10 of x. So they're trying to trick you. So, and this is what they're doing. This should really be written like this. Because this is an up 1. So that's not H because it's not in parentheses. This is K. And the asymptote, okay, so if you did this graph, the asymptote doesn't know H. So you graph this, you graph your asymptote and your points for the log base 10, would be pick a 1, log base 10 of 1 is 0, and pick a 10, log base 10 of 10 to the 1 is 1. So when you reflect x, you negate the y. When you x, you negate the y. And when you go up 1, you add 1 to the y, and you add 1 to the y. And so what you have here is you have right 1, up 1, and right 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here's the most important thing for me to tell you. The most important thing is that your logarithm goes up, but when you reflect over the x-axis, he goes down. So this is what's important to know, that your graph should look like that. So it goes down along the asymptote like that. So make sure you do this when you have reflections. What's that?
It's log base 3.
It's log base 3, this one? Okay, so this would be wrong. So if it's log base 3, this would be right. This would have to be a 3. This would be a 3. And this would be a 3. So write 3, 0. So write 1, up 1, write 3, 0. So instead of it doing that, it's going to drop down like that. And you notice that 47 looks like this. See how it's dropping through 3? But this part was what was important. You have to know what the log, is it time to go yet? No. You have to know what the logarithm looks like. Goes up, and you need to know that when it's reflected over the x-axis, it should look like that. All right, now, all the problems we've done so far, we've done most of the problems on the exam for 3.2. The only problems we haven't done are, there's like 5 left. And I'm not going to give you hints because we had students not showing their face. And so if you're not going to show your face, you're going to cause the class problems and they're going to be getting upset with you. So I got to show your face. But I will let you know there's 3 problems that have, they're 5-point problems. So I'm not going to, I told last period, but you can talk to them if you want. I'm not giving it to you guys. They're asking for multiple work. They're asking for graphs. They're asking for the asymptotes of the parent and the new graph. And they're also asking for the domain and range of the parent and the new graph. So these are the problems that are heavily weighted. All right. So you're going to go to your teams. Actually, let's just walk through it with me. Problem number 53. Is g of x is equal to log base 2 of x plus 1. So you want to get the parent first, which is log base 2 of x. We know there's a vertical asymptote. So what x are you going to pick?
1.
Log base 2 of 1 is 0. Give me another x, please.
2.
Log base 2 of 2 to the 1 is 1. All right. Okay, what's this transformation? Is this A, B, H, or K?
H.
So what's that mean?
It goes left 1.
Left 1, because that's minus a negative 1, because remember, all the forms have a minus in them. All right, that's it. So left 1 means subtract 1. Left 1 means subtract 1. And is the asymptote, does it stay at x equals 0 or does it change?
It changes.
Changes to what?
X equals -1.
Right, because the h moves the vertical asymptote. So we're gonna, let me draw the parent first. So the parent has a vertical asymptote at x equals 0, which is the line. We're gonna go right 1, 0, right 2, up 1, and we're gonna draw the logarithm along the asymptote. So we do know the parent looks like that. There is no reflection, so the new graph is also gonna look like that. The new graph I'll do in red. So there's an asymptote at x equals -1. They want both of these graphs, I think. So the directions say graph the parent, then do the transformation, and they want to know what the asymptotes are. So you would circle both of those. And this graph is going to be 0, 0, right 1, up 1. So this is going along that asymptote. And they're also asking for the domain and range of each. So let's take the parent first. What's the domain of the parent?
0 to infinity.
0 to the right, right. What's the range?
-infinity to infinity.
Forever up and down, right, forever up and down. So now we take our new graph. What's the domain of the new graph?
-1 to infinity.
-1 to the right forever. And what's the range?
Forever up and down.
Forever up and down. So they want the graphs. So this is the heavily weighted problem, one of them. They want the graph. So make sure you know how to do the graph. They want the domain and range of each one, and they want the asymptotes of each one. So this is a 5-point problem. Okay, we have time for one more. Let's do problem number, do you guys want to do 59 or 61?
Can we do 61?
Yeah. $61. H of x equals log base 10 of x minus 1. That is not h, by the way. It would have to be in parentheses. But the parent is log base 10 of x. And the vertical asymptote is always x equals 0 of the parent. All right, so give me an x, guys.
1.
Log base 10 of 1 is 0. Give me another one.
10.
Log base 10 of 10 to the 1 is 1. So that's the parent. Let's graph that. And we'll state the domain and range while we're there. So this is one of the answers they're asking for, is the vertical asymptote. Make sure you write it as x equals 0. So the graph has a vertical asymptote at x equals 0. The points are right 1, 0, and then right 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right 10, up 1. So you draw the graph along the asymptote. And the reason why it's not flat, but the reason why it looks like that is because that number is so big, 10. Okay, so what's the domain?
0 to infinity.
Open on 0 to the right forever. And what's the range?
Forever up and down.
Forever up and down. Okay, go to the next one. State the transformation. What's this?
Down 1.
Down 1. So when we go down 1, This would be down 1 would be -1, and down 1 would be 0. And our asymptote does not change because moving, moving down doesn't change the asymptote. It's H that changes the asymptote. So they would be the same in this case. So the asymptote remains the same. And we graph right 1, down 1. And we graph right 10, 0. And there's no reflection or anything. We just draw the red graph along the asymptote. And we state the domain and range. What's the domain?
0 to infinity.
It's the same as the other one. And what's the range? Forever up and down. So once again, they want the asymptotes of each. They want the domain and range of F, the domain and range of G, and the graphs of both. And that's why it's a 5-point problem. All right, time's up, you guys. I hope you have a wonderful day. I am planning on teaching a new lesson tomorrow. We're not spending all day doing this, so I'm over it at this point. So a new lesson tomorrow. I'll be happy, but make sure you have your questions prepared for the exam. All right, have a great day. I'll see you tomorrow.